Hello children, once again I welcome you all to class 9 science online tutoring class. So far we have done we have covered two chapters, that is chapter 8 and 9. So today we are going to start with a new chapter, that is chapter number 10. In chapter 8 and 9, you have learned the motion of an object, an external cause as the cause of motion, an external force as the cause of motion, and you have also learned that force is needed to change the speed of an object or the direction of the motion of an object, and you have also learned that force can even change the shape and size of an object. Now today in this topic, in this chapter, we are going to learn about other new concept, that is gravitation. So what is gravitation? When I say gravitation, I'm sure all of you are aware of the term gravitation, because since this is not a new word or new term for you all, even though you might not have studied in detail about gravitation, but I'm sure you have heard or you have learned something about gravitation in your lower class. So the question here is, what is gravitation or what is gravity? In order to understand the concept of gravitation clearly, let us look at some of the examples that happens in our everyday life. Say for example, if I drop this pen from some height, then what will happen? This pen will fall towards the ground. That means this pen will fall on the ground. That is, it will fall towards the earth. And not only that, but for example, say a fruit. If a fruit gets detached from the tree, then the fruit will also fall towards the ground. That is, it will fall towards the earth. So the question here is, why does the pane or the fruits fall on the ground instead of just flying high in the air, or it could have just bounced back and then it could have just stayed in the air without falling on the ground, but why did it fall on the ground? That means there must be some force that is pulling the object, that is pane and the apple, towards the earth. And let me give you another example. For example, while playing a football game, if somebody hit or if somebody kicked the ball, then you will see that the ball will rise to a certain height and then it does not stay there in the air, but it falls back towards the ground. So even in this case, there must be some force that is acting on the object, that is ball, and because of which the ball is pulling towards the ground. And we also know that the planets all the planets and revolve around the sun, right? And not only that, but even the moon revolve around the earth in a circular orbit. When I say circular orbit, it means, say this is earth, this is sun. So all the planets revolve around the sun in this way. That means in a circular orbit. And not only that, but say this is earth, and even the moon, it moves around the earth in a circular it moves around the earth in a circular orbit. That means even in this case, the earth or the planets could have just moved in a straight line, but why are they moving in a circular orbit? That means even in this case, there must be some force that is acting on this planet and acting on this moon, because of which they are attracting towards itself. So from all these examples, from these three examples, we understand that there must be some force that is acting on this object, that is pen or ball, or it may be fruits or any other object, and also the planets and the earth, because of which it is attracting all this object towards itself, and because of which the moon and the planets are revolving around the sun and the earth. And that force that is attracting the object towards itself, we call it as gravitational force. So the force with which the Earth attracts the object, we call it as gravitational force. And the concept of gravitational force was first propounded by Sir Isaac Newton. So the concept of force was first given by Sir Isaac Newton. So whenever we hear the term gravitation, automatically the scientist named Isaac Newton and the apple comes to our mind, right? So I'm sure all of you have heard about a famous story of an apple behind this Newton idea of gravitation. I hope you have heard about this story in your lower class. So how did Newton started thinking about gravitation, or how he got the idea about gravitation? In science, behind every discoveries or behind every experiment, there is always a story. So even in this case, behind the Newton idea of gravitation, there is a famous story of an apple. So let me tell you this story, but before that, let me give you a brief introduction of who Sir Isaac Newton is. So Sir Isaac Newton was born in England in 1642, and he is regarded as one of the most original and influential theorists in the history of science. And he was born in a poor farming family. That means his parents was poor and they were farmer. And even though his parents were a farmer, Sir Isaac Newton was not very good at farming. So he was sent to study at Cambridge University in 1661. So during the course of his studies in 1665, a plague broke out in an epidemic disease broke out in Cambridge in 1665, and so he took a year off in that very year. So the story of this apple falling on the head of the Newton was found out in that year. So one day it so happened that while Newton was sitting on a garden under an apple tree, an apple fell on his head. So normally this can happen with any one of us, right? It can happen with you or it can happen with me. But if this happens with you, or if this happens with me, for example, I'm sitting on the garden and then suddenly apple fall from the tree and then hit my head, then what you will do? We will just pick it up and just eat the apple, right? But then because we never tend to think so much about it, but Newton paid a lot of attention on these incidents, and he started thinking, why did the apple fall on his head instead of just flying in the air, or it could have just reached the earth and then bounced it back, or it could have just stayed in the air without falling it down. But why did the apple fall on his head or towards the ground? And the apple fall on the ground is because of the gravitation, because of the Earth's attraction towards itself. And the fall of the apple made Newton started thinking that if the earth can attract the apple, then that means the earth can also attract every other object on this planet. And again, after that, the next thing that comes to his mind is, if the earth can attract the apple, then why can't it attract the moon? So that is again another big question, right? If the earth can attract any other object on this planet, then why can't it attract the moon? So the question here is whether the earth attracts the moon or not. So in order to understand, so we see the moon every night, right? We see the moon every night. So have you ever seen the moon falling towards the ground? We never see that, right? We never see the moon falling towards the ground. So there were so many questions in Newton's mind, and then so many questions were in Newton's mind, and all these questions started bothering him. And so he went for a research, he did so many experiments, and finally he came out with a famous universal law of gravitation. And so finally he came out with a famous universal law of gravitation. But before we study what universal law of gravitation, let us see whether the earth attracts the moon or not. Whether Whether the Earth attracts the moon or not, let us find out this. So we all know that the moon revolves around the Earth in a circular motion. That means, as I have said earlier, this is Earth. Moon is revolving around the Earth in a circular motion. That means the motion around the Earth is due to a force, we call it as a centripetal force. Then what is centripetal force again? Centripetal force is nothing but an inward force on a body moving in a circular motion on another object. I repeat again, centripetal force is nothing but an inward force on a body moving in a circular motion, or we can say moving in a curved motion on another object. So that means it is because of the centripetal force. This force is attracting the moon at every point. That means if the moon comes at this point, because of this centripetal force, it is attracting towards itself. The moon will again come at this point. Again, the moon is being attracted towards the center, towards the Earth. And because of this, the moon is moving in a circular motion. Otherwise, if the Earth is not attracting the moon, then the moon would have gone in a straight line path. So in order to understand this, let us do one activity. So in this activity, all you need is a thread and a small stone. So I want you all to tie that small stone on one end of the thread and hold the other end with your hand, and then swing the stone. So if you swing the stone, then what do you observe? What do you see? The stone will move in a circular motion, right? Just like this. The stone will start rotating in a circular motion. That means why it is moving in a circular motion is because you are applying a force with your hand that is at the center. It is because of the force that you are applying at the center, the stone is being attracted at every point, and because of which it is moving in a circular motion. And this force, the inward force, we call it as a centripetal force, as discussed earlier. So now, after swinging it, you try to release the stone. You try to release the thread. What do you see is the stone will fly away in a straight line path, right? So that means similarly with the moon and the Earth. At the center, that is, just imagine the moon as stone and Earth as the center, your hand. So imagine in this way, okay, so that you will understand it very clearly. So imagine the moon as a stone and then the Earth as the center, or the center, that your hand. It is because of the centripetal force the moon is being attracted at every point, and because of which the moon is revolving in a circular motion. Otherwise, the moon would have taken a straight line path. So from this we understand that the Earth attracts the moon because of a centripetal force, and that is why the moon is revolving in a circular motion. So now let us see what is universal law of gravitation. Universal law of gravitation states that every object in the universe attracts every other object with a force which is proportional to the masses of an object and inversely proportional to the distance between them. Let me write this definition. Every object in the universe attract every other object with a force which is proportional to the product of the masses So universal law of gravitation states that every object in the universe attracts every other object with a force which is proportional to the product of the masses and inversely proportional to the square of the distance between them. So that means if two objects are placed very close to each other, since the distance between them are less, and therefore the force with which they attract each other will also be more. So let us say there are two objects A and B. Two object A, say this is object A and then this is object B. Okay, so this is object A and then this is object B. So according to universal law of gravitation, the first part, see, every object in the universe attracts every other object. That means every object, if we place two objects together, then they will start attracting each other. This is according to universal law of gravitation. But have you ever seen if you keep two objects on a table, say one pen and another pen on a table, do they start moving towards each other? Or have you ever seen that if we keep two objects on a table, do they start moving or do they start attracting towards each other? We never see that, right? Because the force of attraction between these two objects is less. The two objects will attract only if the force is more. That means the greater the force, the more will be the attraction of an object. So again, so let us say the first object is A and the second object is B, and let's say the mass of first object is capital M and the mass of object B is small m, and the distance between them is, distance between A and B is, let's take it as D. So according to universal law of gravitation, the second part, attract every other object with a force. Okay, with a force, that means force is nothing but F, all right, force which is proportional. Again, this which is proportional means this is the proportionality sign, which is proportional to the product. Product means what? Multiplication, right? To the product of their masses. So here mass we have capital M and small m. So product of their masses means capital M into small m. So we can just write M, capital M and small m. Let's take this as equation 1. Again, the last part of this universal law of gravitation is inversely proportional. That means this force again. This force is inversely proportional. So this force is inversely proportional means 1 divided by, right? So inversely proportional to the square of distance between them. What is the distance here? Distance is D, right? So distance and then square. So this is square. So let's take this as equation 2. I'll rub this. So we have got equation 1 and equation 2 from universal law of gravitation. So if we let's combine this equation 1 and 2. So on combining equation 1 and equation 2, what you will get? In equation 1, on the left hand side we have force, and equation 2 on the left hand side again we have force. So let's take this one force as common. And then proportionality, equation 1 we have m into m, and then equation 2 we have d square. So now we can write like this. Since nothing is there on the denominator, that means 1. So capital M into small m into 1 is nothing but m, and then as it is. So here we have a proportionality. So in order to convert this proportionality into equality, that means in order to convert this proportionality sign into equal sign, we will introduce a constant, and here the constant that we are going to introduce here is nothing but capital G. So F is equal to capital G and it will remain as it is. So we have converted this proportionality into equality, and so we have introduced this g. Now what is this g? This g is nothing but this g is a constant, universal gravitational constant. So this g is universal gravitational constant. So this is the famous universal law of gravitation, and the unit of universal law of gravitation is Newton meter square per kg square. The unit of universal law of gravitation is Newton meter square per kg square, and this value of g, the universally accepted value of g is, this is a constant value. It will not change, okay? It is a constant. So universally accepted value of g is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is the universally accepted value of g. I want you all to memorize this. Since this is a constant value, it will not change. And when you do your numerical problems, you will be using this, the value of g, and also the formula of this universal gravitational constant. So I want you all to memorize this too. So this is all about universal law of gravitation. Okay, now the next topic is free fall. So what is free fall? Just by name itself, see, free, that means, free fall means falling freely, right? Falling freely without any obstruction. So in order to understand the meaning of the concept of this free fall, let us again do one activity that is given in your textbook, page number 144, activity 10.2. Page number 144, activity 10.2. So I want you all to pick up a small stone and throw it upward. What will happen? The stone will go to some certain height, and then it will fall back towards the ground, or it will fall back towards the earth. And we have already studied, we have already learned that it is because of the gravitational force of the earth, it is attracting the object towards itself. So here in this case, free fall, whenever an object falls towards the earth, whenever an object falls towards the earth with no other force, here, with no other force acting on a body. So this part is very important. With no other force acting on a body except the gravitational force. So whenever an object is falling on the ground with no other force acting on the body except the gravitational force of the earth, then we can say it as free fall. That means in this case, there is no other force acting on the object except the gravitational force of the earth. Again, another question here is, as the stone keeps falling towards the ground, what do you think? Will the velocity change, or will the velocity will remain same, or will the velocity will increase or decrease? That means as the stone starts falling down from some height to the ground, will the velocity means speed, right? So that means, will the speed change, or will the speed will increase, or will the speed will decrease, or the speed will remain as it is? So here in this case, the speed of the stone will keep on increasing as it falls towards the ground. That means the object that is the so here the object is stone, right? So the object will keep on increasing as it falls towards the earth. Means the more the force from the universal law of gravitation, we have already studied that the more force, the more attraction it will be. So as it comes close, as the object that is the stone comes closer to the earth, the force of attraction will be more, and that is why the force, the velocity or the speed keeps on increasing as the object falls from some height to the ground. So that means velocity or speed, change in the velocity or change in speed, that means it involves acceleration, right? Acceleration means increasing in speed. So that means whenever an object falls towards the earth, acceleration is involved. And here acceleration is due to Earth's gravitational force. So that means the acceleration here is, we call it acceleration due to gravity. And this acceleration due to gravity is denoted by a letter small g. Don't get confused. This small g is acceleration due to gravity and the capital G is universal gravitational constant. So don't be confused with this capital G and then small g. Small g is acceleration due to gravity and then capital G is universal gravitational constant. So acceleration due to gravity, from Newton's second law of motion, we know that from Newton's second law of motion, we know that force is equal to mass into acceleration. But here, since acceleration is due to Earth's gravitational force, so it will be acceleration due to gravity. And also from universal law of gravitation, we know that force is this is the value of F. So let's put this value here. If we put this value in this Newton law of gravitation, Newton's second law of gravitation, then so here we have put this value of this F in this equation. So since here we are talking about, we are going to find the expression for acceleration due to gravity, that is the capital small g. So let's bring the small g to one side and then the other to the another side. So here g, so small m and then small m cancel. So we got what? So this is the expression for acceleration due to gravity, and the value of this g is 9.8 meter per second square. This is the value of acceleration due to gravity. Since we are running out of time, so we'll stop from here today and we'll continue this chapter in the next class. So today we have learned that it is because of the gravitational force of the earth. It is because of the gravitational force of the earth, it is attracting the object towards itself, and also because of the centripetal force that is acting on the it is because of the centripetal force, the moon is being attracted at every point, and that is why it is revolving around the earth in a circular motion. And we have also learned that when two objects are lying very close to each other, since the distance between them is less, and therefore the force of attraction will be more. That means the greater the force, the greater will be the movement of an object. And we have learned about free fall, that whenever an object is falling towards the earth, whenever an object is falling towards the earth with no other force acting on the body except the gravitational force of the earth, we call it as a free fall. And also we have learned that whenever an object falls towards the ground, velocity, as it falls towards the ground, the velocity will keep on increasing, and this velocity is nothing but the acceleration. And acceleration is because of the Earth's gravitational force, and we call this as acceleration due to gravity. So with this we will conclude and we will continue the remaining topic in the next class. Thank you.